time when we go through them. So let's have a look at this first drill. How many centimetres in a metre? You need to know all those sorts of things, number of grams in a kilogram, etc. Remember what we were saying this morning about square metres and cubic metres, in fact. There are not 100 cubic centimetres in a cubic metre. How many cubic centimetres in a cubic metre? How many cubic centimetres in a cubic metre? 1,000,000. Right. It's 100 times 100 times 100 because it's a cubic metre. So 1,000,000 cubic centimetres is 1 cubic metre. Shorthand way of writing 1,000,000? 1 times 10 to the 6th, yeah, or just 10 to the 6th because it's taken as read, there's no number in front, it's a 1. So 10 to the 6th cubic centimetres is 1 cubic metre, for example. So beware of those things. If you're talking about square or cubic units, you've got to multiply up. Number 2, answer 5, good, okay. 3 minus 1, I've got to do the brackets first, so 3 minus 1 is 2, 3 plus 1 is 4, so 2 squared is 4, 4 fours are 16, plus another 4 is 20, over 3 times 2 is 6, so I have to do that first because of bid mass, and then I do the subtraction, 6 minus 2 is 4, 20 divided by 4 is 5. So with a bit of practice you can hold that information in your head and just do it, okay? When we talk about algebra, which we will do, then these laws of bid-bass become very important, the order of operations. Not that they're not important with numbers, of course. I mean, there's only one answer to this if you follow the laws of bid-bass correctly. So they're important. Maths is a very logical subject. That's why I like it. You know, there's only one answer. You can't write an essay for hours and hours and hours and you never know whether you got the right answer or not, or you've done enough work with maths, you know. It's about logic. It's all about logic. And while I'm on that little subject, people often ask me, you know, why are we doing this maths? This is an engineering course. Well, and am I going to use this maths that we're doing? Probably a lot of it, no, actually. You know, you are learning the basic bricks and grammar and rules of maths, if you like, that you'll apply to other things. But if you never use this maths, what you're also doing is you're learning how to think logically in steps, and those sorts of skills do apply to everything. It's a very mathematical subject. Mathematics is logic in a lot of ways, so it is important to think mathematically, even if you don't think you are, you probably are in your engineering. Right, well, we did something like this morning, so hopefully in your calculator you entered pi times 50 squared to get times pi, sorry, say again your answer, pi times 50 squared? 7.85. That's okay. So you've rounded that, haven't you, Daniel, to what have you rounded that to then? Well, I can see 3 there. So you've rounded it to 3, have you? And that's probably a bit over the top because that's only 1. But you've rounded it to 3. What else has got to go here? What squared? The unit, which is, no, I've just multiplied 50 millimetres squared by pi. Yeah, so it must be a millimetre squared. I get the unit from that. And then I would put the accuracy in. Well, 3 is probably a bit too many, Daniel, but as you've given it to me, 3 significant figures, okay? So issues around this. If I do this calculation, you get this 2,500 pi. That's an exact answer, but pi is not an exact number in decimals. So this calculator will give you the exact answer, which is 2,500 pi. If I want to know what that is as a decimal, I have a button on here, S to D. S stands for third, and that's a sort of fraction or the rational number form of it. So as a rational number, pi is just denoted by the letter pi. And so you'll often see the third given as a fraction. For example, 3/5 would be the answer. So that's in third form or fraction form. This stands for decimal. So if I want it as a decimal, I hit that button, it would give me 3/5 as a decimal, which is 0.6. So if I want a decimal, I hit that button. Often handy to have it as a fraction, because if I have an answer like 2/3, for example, then that's an exact answer, 2/3, but as a decimal, you get 0.3333 and so on, and so not an exact answer. Something else I was going to mention about this from this morning, somebody asked me the question, can we use calculators? Yeah, to do it, but when we put calculators in, could we have estimated this? Could you have said to yourself, what's 50 squared and got 2,500? 5 5 to 25, put 2 noughts on. What's pi? Roughly 3. So 3 lots of that is about 7,500. So when I actually do it, I know that looks reasonable, okay? And then I know that I'm not making a silly mistake that I could easily do by pressing the wrong button on the calculator. Okay. Next one. 1/2 times 3/4 is 3/8. Good. I just multiply top and multiply bottom. 3 1s are 3, 2 4s are 8. Number 5, round to one significant figure. 10, good. 10 to one significant figure. There's the first significant figure, second, third, fourth, and so on. So if I'm going to round to one significant figure, I just look at the second number, which is a 2, and as that's a 2, this stays as a 1. So 1 is the answer, but I must put the 0 in to hold that in the right column. So, yeah. No, because to the nearest whole number, it would be 12. Oh. Yeah. Okay, I'm rounding to one significant figure, so 1's figure. But then I must put the extra 0 on, agreed? Otherwise it looks just like 1. Yes, it would, yeah, that's right. Anything less than 15, it will be 10 to one significant figure, yeah. Something we don't do very often, but useful for estimating, and one significant figure will do to give you the rough answer. In engineering notation, 136 times 10 to the 6, or meg, you're right, yeah, dead right, okay. But that's what we mean by engineering notation, times 10 to the 6, okay. Any other answers? Correct. And you could easily need to do that if you want whatever you're measuring to be in kilo something. And so if I'm working routinely in kilovolts or kilojoules, then I want my answer in kilos, not megas. So I'd call it 136,000. Any other possibilities? Right, times 10 to the 9, yes, which is giga, whatever it is we're talking about, okay? So there's no one answer to that. The only thing is is my power a multiple of 3? If it is, then it's in engineering notation. If I was working with computers a lot, I might well want to know that's 0.136 gigabytes rather than 136 megabytes. Okay? So it all depends on the situation. Number 7, estimation. Somebody on the back row. 154. How worked out? Yeah. And how did you times it by 11? Yeah. Right, and added another one. So times by 10 is 140, plus another 14. Whoops. Another 14 gives me 154. Yeah, that's probably what I would have done. Okay. High or low? Yeah, a bit high because I've rounded up. Comment if you've done it in a different way, but I will move on unless you want to, desperate to say something. Number 8, well, we've looked at this already, so in engineering notation, someone on the middle. I agree with the 10 to the 3. What did you say first? No, we can't change the position as a decimal point. Yeah? 3.9 times 10 to the 3. All kilo means is 10 to the 3. That means times 10 to the 3. Okay? So you don't change the number at all. Number 9. Estimate the power when the voltage is at. I did give you a little bit of a help by with the units, kilo and milli. What do? They effectively cancel each other out. Yes, kilo is times 10 to the 3, milli is times 10 to the minus 3, so actually they effectively cancel each other out, because when you multiply, you add the powers, 3 minus 3 is 0, so they cancel effectively. So it ends up being just 3.9 times 2.14. So if I'm going to estimate this, 4 to one significant figure, 2 to one significant figure, so that's going to give me around about 8 watts. And then I get my calculator out and I work it out. Can you work out what that is with the calculator, please? So you need to convert that to engineering notation, so 3.9 times 10 to the 3, and that to engineering notation, so 2.14 times 10 to the minus 3, and you should get roughly 8. Three, 4, 6. So this would be 3.9 times 10 to the 3, and that would be 2.14 times 10 to the minus 3. Okay, let's have a look. 8.346, so you're giving me 4 significant figures, Daniel. Again, an issue there, look, 2 there, 3 there, but only 2 there, so you can't really go more than 3. So give it to me to 3 significant figures. 3 significant figures. That's 2 significant figures. 3? Yeah. Watts to 3 significant figures is a better answer, okay? So what do I put into the calculator? 3.9 times 10 to the 3, so that's the first one, multiplied by, what was it? 2.14 times 10 to the minus, that's that minus button, or plus minus on some, yeah, 3 equals, and that's what you put into the calculator, okay?